Question 2. So this is more of a higher level question. It involves trigonometric functions and trigonometric. The way we would do this question is we need to know a few properties first. I'm going to list them down here. So we need to know that secant x is actually nothing but 1 over cos x. All right. And then tan of x is nothing but sine of x divided by cos of x. And one more formula or property of trigonometry which we need to know and we will use is that sine squared of x plus cos squared of x is actually equal to 1. So with these in mind, we can start approaching this question. We'll look at the left hand side first and try and prove that the LHS is equal to the RHS. So looking at the left hand side, we have cos x over secant x minus tan x. So as we said earlier, we can simplify secant x and tan x in their forms as we wrote above. So what would they become? So if we use these two to simplify this equation, we would get cos x will remain cos x on the numerator. In the denominator, secant x will become 1 over cos x plus, it's actually a minus tan x would become sine x over cos x. So taking this further, we can further simplify this. The way we would do that would be we can use these two terms and carry on the subtraction. So since cos x is the now common denominator, we won't have to cross multiply and we can straight away do the subtraction. So we would get cos x over 1 minus sine x divided by cos x. Cos x can actually go in the numerator now since it's being divided, and we would be left with cos squared of x divided by 1 minus sine of x. At this stage, we need to remember that we had this property where we said sine squared x plus cos squared x is 1. So similarly, from that property, we can also say that 1 minus sine squared x is actually cos squared x. I'm just gonna draw a bubble around it so you remember this is what my thought process is. And then carrying this forward, I'm gonna use my thought process as our friend above and try to get to that. So the way I would get to that is if I look at the denominator, I have 1 minus sine x. But if I need to get it to 1 minus sine squared x, I need to multiply the numerator and denominator by 1 plus sine x. So we can do that. Since we're dividing and multiplying by the same number, it does not affect our expression at all. So now with this division, what we get is on the numerator we get cos squared x times 1 plus sine x, but on the denominator we get 1 minus sine x times 1 plus sine x. We would have to recall that one of the multiplication property is that a minus b times a plus b is equal to a square minus b square. So we can use that property here to further simplify this expression, and we would get cos square x times 1 plus sin x divided by, we would get 1 square minus sin square x, and then 1 square is nothing but 1, so we will leave that as is. So this should look familiar to you. This was exactly what we had written in our thought process example as we showed above. We can simplify this and write this as cos squared x. So if I substitute cos squared x instead of 1 minus sin squared x, I would be left with cos squared x times 1 plus sin x in the numerator, and then cos square x in the denominator. This cos square x and this cos square x would cancel out, so our final answer would be 1 plus sin x, which is what was the RHS or right hand side in the given equation which we were asked to prove. So therefore we were able to prove this, that cos over secant x minus tan x is actually equal to 1 plus sin x as well. We can also do the same thing from the RHS. So if we started with 1 plus sin x, we can go all the way and prove that it is equal to cos x over secant x minus tan x as well. But in this example, we chose to start from the left hand side. Okay, let's look at the solution. So they've identified all the properties we'll be using, simplified it, multiplication, perfect. Okay, so instead of doing it exactly the way I did it, what they've done is split cos square x and 1 minus sin square x, and then split it further, which is also correct. Okay.